Hey guys, welcome to my channel. I'm LeetCode, and today we have a pretty interesting problem for you guys, man. We're gonna be talking about course schedule, guys. So if you guys are new here, man, you guys should consider subscribing, guys. We do a lot of data structure and algorithm videos here, and we are building an awesome community here. So consider subscribing and join this community that we have here. So let's get into the video real quick. All right. So he says the problem's called course schedule, right? You know what I'm saying? So he says there are a total number of a total num courses, right, that you have to take. It says labeled from 0 to num course minus 1, right? You're given an array of prerequisites, right? Where prerequisites of I, right, is equal to A sub I, B sub I, indicates that you must take course B first before you can take course A, right? You know what I'm saying? That's the format that the courses are represented in, right? And they give us an example right there. It says, for example, pair 0, 1, right? Indicates that for you to take course 0, you have to take course 1 first, right? I'm saying, so that's the relationship that, they represent, what I'm saying. So, yeah, so it says return true if we're able to finish all courses, right? It says otherwise return false, right? So num courses, right, is equal to 2. And then we got a prerequisites array, right? Same. Okay. He says, yeah, so we're given num courses, right, which pretty much tells us the number of courses that we have, and then we got the prerequisite, right, which tells us the courses that we have. So with this example, right, you know what I'm saying? So to take course 1, right, we have to take course 0. So there, we could take all courses, right, where it's possible. So because there's 2 courses and so after I take course 0, I can take course 1, right? I'm saying I'm in good shape. I can finish it. So we have num course 2, right? And we have an extra piece of data, right? So he says, so same thing as before, right? We can take course 0, right? And then we take course 1, right? But this one says, right, that in the thing that they have, right, to take course 0, I gotta take course 1, right? There's gotta be a mistake. So I can't take those courses because it tells you exactly why, right? You know what I'm saying? Because if 0 is a prerequisite for 1, right? For course 1, how can course 1 be a prerequisite for course 0? That's not possible, guys. What I'm saying. So guys, how can we solve this problem, guys? How can we solve this problem, right? So what we can do, guys, so we got a bunch of elements, right? So pretty much we could kind of model this as a graph, right? Pretty much we could, the courses, right, can pretty much represent nodes in the graph, right? I'm saying, and we could show the relationship between the different nodes with a directed edge, guys. So if you guys know what I'm talking about, guys, I have a playlist bar graphs. So I went all over the different types of graph and the different edges that are there, right? So pretty much we're gonna have the courses are gonna represent nodes, right? And the edges, directed edge, pretty much gonna let us know that for every node, right? You know what I'm saying? If let's say for this example, right, we would model it, right? 0 would point to 1, right? Meaning that that 0 is a prerequisite for course 1, right? Which represent that's how we would show that relationship, right? So 0 would be a prerequisite for 1, right? So 0 would point to 1, right? Meaning that 1 is dependent on 0, I'm saying. So we could easily, guys, we've talked about this algorithm before, right? The topological sort, guys, to pretty much kind of see if we can find a topological ordering of the elements, guys. So after we do that, guys, if we're able to successfully do the topological ordering of all the elements, right? So then we could conclude that, then indeed we are able to take all the courses, right? Yeah, since that's what I'm saying. So if we successfully do all the topological order, because we know topological sort, guys, is used to find a linear ordering of elements, right, that have dependencies on each other. So yeah, guys, so if we do that, then after that, we're all good, right? So let me take you guys to my iPad, right? We're gonna run through a couple of examples real quick. and hopefully it makes sense after that. So it can be a lot clearer to you guys, right? So we're just gonna do the first problem, guys, which is we said, let me turn on my pen. So course 0, right? I'm saying is a prerequisite for course 1, right? Course 1, right? And then yeah, we are able to take that course because, guys, we can take course 0 first, right? Course 0, and then we take course 1, guys, right? Right? Easy, you know what I'm saying? So pretty much we would apply, guys, the topological sort, guys, what I'm saying, to kind of solve this problem, right? To find the, because I told you guys in the last video that I made, guys, topological sort is used to find a linear ordering of elements that have dependencies on one another, right? You know what I'm saying? So topological sort serves that purpose, since we have the courses, right? And then we have a directed graph, right? And then yeah, we could easily apply topological sort, right? So pretty much what we're trying to do, right? What I'm saying, we're pretty much going to try to see if we can find a topological ordering, right? Meaning we can take all the courses, right? I'm saying we can find topological ordering of the graph, right? So if we're able to find that, and we're able to take all the courses, right, we can conclude that we can take all the courses. You know what I'm saying. So even the other example, right, I'm saying that we have, right, so the other example that we have, the second one, right, make sure that you guys remember, which is this one, right? I'm saying, so it said, right, that to take course 0, to take course 1, right, we take course 1, and we draw that. To take course 1, right, course 1, right, we have to take course 0 first. You know what I'm saying? That's what it said on the thing, right? But it then says again, right, that to take course 1, right, course 0, we have to have taken course 1, right, which is not good, guys. This graph is cyclic, right? There's a cycle in the graph. So I'm saying, so for topological sort to successfully work, right? You know what I'm saying, it needs to be a directed acyclic, right? Which means there aren't any cycles in the graph, guys. What I'm saying. So that's what we're gonna go with. If we're able to successfully do the topological sort of the graph, right? We can say, we can take all the courses, guys. What I'm saying. So I've done a video on that already. So if you guys haven't seen that, I would highly suggest you guys go check it out, because I went through a lot of details, what I'm saying, and over the steps that we're going to apply, right? So we're going to do a quick walkthrough real quick, right, of this particular example, right? So yeah, let's do an example for how the topological is going to work, guys. So pretty much this one's a very, very simple case. Pretty much what we do, guys, we build a graph, right? After we build a graph, we put all the source nodes that pretty much nodes with degree of 0, right? I'm saying, so this is 0, this is 1, right? And then 0, we start with 0, right? And then we process 0, right? So what we're going to do, guys, we're going to print 0, right? To simulate that course is taken, right? If we process it, course is taken. So we're going to put 0, right, as a course we've taken, right? So now after we take 0, guys, we know that we are in good shape. So 0, right? Since we've taken 0, that means that we're now eligible to, because this one had an integer of 1, right? So we subtract -1, could be decremented, since we have one less prerequisite that we need to worry about. So now 1 minus 1 gives you 0. So if the integer now is 0, right, we can add it to the queue, guys. What I'm saying, so we've taken 0 already, so that's why I removed it, right? So we can take it, so we put 1 in the queue for it to be processed, right? So now we process it, right? We take 1 out, and then now and then after we're done, guys, we check were we successfully able to take all the courses. If yes, then we're in good shape. We have nothing to worry about, and then we're good. So we were successfully able to take it, right? So if we weren't able to take all the courses, what I'm saying, if we were unable to, then we're gonna return, guys, false, because we're not able to graduate on time. So let's go back to the to the LeetCode, right, and start coding it up, right? So it's gonna be quite long, guys, very long. A problem, right? So let's quickly start typing really fast, guys, right? So hopefully you guys will be able to understand the intuition, and now everything should be relatively straightforward. So now what I'm going to do, guys, we're going to build and we need to be able to represent the graph, right? So how do we represent it in code, right? We're going to be using the adjacency list, guys, what I'm saying. So if you guys haven't seen my, if you guys haven't seen my video on that, right, where I went through all the graph representation, something should pop up, guys. There's a lot of prerequisite videos that you guys should go through before you guys can kind of understand topological sort, guys. So guys, yeah, so let's get started real quick. All right, so what we're gonna do, guys, so guys, we're gonna represent the graph in adjacency list, right? So let's have a map of integer to integer, right? So a list of integers, right? Pretty much all the neighboring nodes that it has, right? Let's call it G, right? Let's call it G for, let's call it G for graph, right? So I was trying to say, pretty much, guys, what we're gonna do, we're gonna pretty much loop, so it's kind of initialize everything, right? That's the initializing steps that we're doing right now. All right, so we do G that put, we're gonna put I in new array list, right? So pretty much we're initializing every list, okay? So that we could add stuff to them, right? What are we gonna add? We're gonna add all of our neighbors, right? So for 0, right? 0 would add all of its neighbors, right? So it's not gonna make sense now if you guys haven't seen my other videos about that, right? So guys, we also need another additional data structure, right? To kind of pretty much keep track of the in degree, right? So very important, guys. Make sure that you guys have that, right? Okay, so after we do that, we are in good shape. So we got that ready. So we initialize every list, and then we also need to initialize the n degree that puts I with 0, right? So we're good. So now we can start building the graph now, right? So this is where the fun thing begins, right? So this is I don't know how to spell that word. It's a very weird word, guys. So what's next? What's gonna be next for us, guys? So we pretty much gonna build the graph, right? So pretty much courses, right? So I'm gonna fill that up a little bit. So we know it's gonna be a parent to child kind of type of relationship, right? So that's how we're gonna treat it. I'm saying, yeah. So guys, they said, right, that for us to take course A, right? So if we want to indicate that you must take course B, right? So we need to take course B first, right? We need to take course B before we take course A, right? So this pretty much means that, the parent, right, has to be the second index, right? And the child's going to be the first index, right? Since A is dependent on B, right? What I'm saying? So that's what I'm doing right there, right? Okay, I'm sure it's extremely clear to you guys, right? So, and after we do that, guys, we do G that get parent, right? Get the parent, and then add that node as my child, guys. I'm saying it's a neighboring node, right? So we do that. Else, what we're gonna do next, right? We do the n degree that we put the child, right? We do n degree that gets child, right? And then we do +1, right, to increment it, right? Keep incrementing the n degree of that node, right? So we build the graph, guys. We are in good shape. So now we know we're gonna start doing the breadth search traversal. Now we know we're gonna be using a queue, guys, to do that, right? What I'm saying. So this thing is gonna be a queue of integers, right? Queue, then new like lists, right? Okay, and then what we're gonna do, guys, we need to find all these source nodes, right? All right, so yeah, so we're gonna loop through every single, right? Every single courses, I'm saying. And then we're gonna check, right? If there's any node, right, that does not have any dependencies, right? It doesn't have any prerequisite, right? So that those are the first courses that we're going to take, right? So any course that does not have any dependencies, we're going to take that course, right? That's exactly what we're doing here. So we add it in there, right? And then now this is where the fun begins, guys, right? So while the queue's not empty, right? So we take one node at a time, guys, right? So we start visiting the nodes one at a time, right? And then as we're visiting, guys, we need to keep track of, the amount of courses that we've taken, right? Courses taken, right? So I've taken 0 courses so far, right? Now I'm trying to graduate. So every time that we see one, we visit, we take a course, right? We visit it, right? We're gonna increment the counter, guys, right? And then, guys, yeah, so we take that course, right? So we take 0, right? The first course, and then we visit all of our child, right? Child nodes, and then we get that because they're, we have the agency list, so we can easily do that, right? And then, guys, what we do, guys, we decrement the n degree, right? That put child, the n degree that get the child, right? And then we subtract, guys, the n degree because we're not accounting for that course, right? I'm saying for that course that we're just taking, right? So let me make it descriptive, guys. I'm saying course, right? So we're not accounting for that course anymore, right? So we're not worried about it. So we decrement that n degree, right? And of that child node, right? What I'm saying, which is very, very important, guys. So you guys might, yeah. So yeah. So I was gonna show you my iPad, but it doesn't matter. So that's it's you guys can understand it, right? So we take the n degree, right? We get the n degree of that child, right? After we removed, so that child course, right, has one last course that it needs to worry about since we've just taken that course right there, right? So now after we've subtract the n degree of that particular node, right, we check does it equal to 0. If it does equal to 0, right, then I'm finally I've fulfilled all the requirements, right? So now I can successfully take that course, guys, which is very, very cool. I'm saying we add that child in there, and yeah. So after we do that, right, we are in pretty good shape. So we pretty much, after we're done, we need to do a check right there, guys. If the courses taken, right, equals to the num courses that's passed into us, right? Pretty much the number of courses that I have to take, right? That's what they said, right? I'm saying. So let me sure that I got it right. Num courses, true. So if it equals, right? If it's the same, so I was successfully able to do the topological ordering, right? That's pretty much what this means, right? So we build a graph, right, with all its dependencies, right? And then we see, can we be able to apply topological sort, right? Where we're successfully able to do the topological ordering of all the elements, right? You know what I'm saying? So yeah, if that's the case, guys, we return true. You know what I'm saying? If it's not, we return false, meaning that we're not able to graduate, guys. Or not good. Let's see if we're in good shape, guys. So I'm saying, so okay, we got some stuff here, right? So if equals to 0, I'm saying I'm tripping. Okay, cool. Seems like we are passing small test case. So let's press submit, guys. See if we pass anything. Perfect, guys. We're about to pass all the test cases, guys, on the first try. So that's very, very good, guys. Very, very happy about it. So yeah, man. Like I said, guys, if you guys haven't subscribed yet, guys, I will advise you guys to subscribe to this channel because we have a lot of fun here, guys, and we do enjoy ourselves. So I want to thank you guys for watching this video, guys. So I'm saying, and yeah, I'll see you guys in the next one.